Hello and welcome back to solving trigonometric equations. It is lesson 1F, so we're looking at example number 6. So we've gone through some degree questions and some radian and a radian question. Here's a second radian question. How do I know it's radians? Because in the question it says solve for x between 0 and 2 pi, so I know I need to work in radians. Again, what difference does that make to me? The only thing I do differently, I make sure my calculator is in radian mode. And instead of adding on 360 degrees to generate any extra solutions, I add on 2 pi radians. Apart from that, everything else is exactly the same. So 3 tan of bracket equals 0.5. So let's have a quick look at the graph to see what we're actually trying to work out. So here's 3 tan of 2x plus 0.2. So let's look at when that is at a height of 1/2. So we have between 0 and 360 here, we have 4 solutions. I've also highlighted this 5th solution, which is just before 0. So it's just out of the domain we're looking for. But as I'm solving 3 tan 2x plus 0.2, I know that the curve has been moved to the left by a small amount. So this value here might not be valid. So this, in my working, halfway through the question, this value might be in the domain. And then when I subtract the 0.2 at the end of the question, this might be dragged out of the domain. So I might have to look at this value up here as my 4th value. I'll come back to that again. I might have lost 1 or 2 of you there. I'll come back to that at the end once we've actually found the values out. So let's divide through by 3. Find the inverse tan of 0.5 over 3, or the inverse tan of 1/6. So that is 0.1651 radians. We are doing a tan question. It is a positive value of tan, so therefore we're looking in the 1st and the 3rd quadrant. So it's normally 180 plus there, but we're in radians, so it'll be pi plus. So 0.1651 and pi plus 0.1651. And it's tan 2x, so twice as many solutions we're looking for. Remember, we've seen that from the graph. So I need to add on 2 pi to both of these solutions here, which will give me 6.448 and 9.59. Now I need to subtract 0.2 from every single value. So this value here, 0.1651, when I subtract 0.2 from it, it actually becomes negative. So let's look at that. So when I'm adding 0.2, this becomes negative. So sorry, when I'm subtracting 0.2, this becomes negative. So what's happened here, this value, before the horizontal shift associated with the 0.2 in the bracket, was sitting just to the right here. So it was just sitting in the domain. That horizontal shift has dragged it out of the domain 0 to 360. So we don't have this as a valid solution anymore. But this one up here, originally before that horizontal shift where it was dragged a little bit to the left, so originally that was sitting here just over 2 pi. And as this first one down here was dragged to the left and out of the domain, this one up here was just to the right of the domain and it was dragged into the domain. So basically, once I've got this and notice it's too small, I just simply add on 2 pi to get this value up here, because we know the period of the tan graph, so we can add on 2 pi to get this top value. Or if it was a degree question, guys, we know this would repeat 360 degrees later, so we'd add on 360 if we're doing it in degrees. So I've divided through by 2. This is not in the domain. So I've made a statement there, out of the domain 0 to 2 pi, so I add on 2 pi to find the extra solution, because I should be getting 4 solutions if it's tan 2x. Okay, so negative 0.017 plus 2 pi, which is roughly 6.28, so it's going to come in just under 6.28, which it does. Okay, and again, that's because we have that plus 0.2 there, which drags the tan curve a little bit to the left, which has dragged that value out of the domain, which is why I'm looking for this one further up.